of different companies because a lot of different companies use Zeppelin, and the team asked me some help because sometimes Zeppelin have some problem. So I have an opportunity to meet a lot of different teams and have an opportunity to see how they actually work in their data project. So I'd like to share some of those experiences here.
Yeah, and for myself, I have had the experience kind of on the other side of the house as the analyst, as the consultant, with working with business requirements, and so we hope our talk kind of meets in the middle. So a little bit about the Zepl story. We kind of already touched on it, but Moon created the open source Apache Zeppelin in 2012. We founded Zepl in 2016 to kind of serve the enterprise users, to give them the features that they needed to help teams of data scientists work together. And so ultimately we launched our platform as a SaaS product in 2018. And we've gotten great adoption at different companies such as Uber, Samsung, and we're working as well with partners such as Snowflake, Apple, etc. And so, yeah.
Yeah, and I'd like to start from data science lifecycle. I think most of the data science projects start from the problem, identifying the problem, what problem you like to solve by building your model. And to build your model, you probably go to your data and you build with some data, and sometimes it's 80% of your work. And then you set up your hypothesis and experiment and train, and somehow you build your model, and then deploy your model to the production and monitor your model, how it works, and probably repeat these iterations and more. I think if you can build your model, the perfect model from the first iteration, you don't have to have multiple of these iterations, but I think usually you will go through multiple iterations to improve your model. So I think it's really important not only building your model very well, but also how quickly you can go through these iterations. It's also really critical factor on your model because we'd like to improve over time. So unfortunately, there are a lot of different components related to your machine learning system. I think this is a famous diagram that you probably saw somewhere before. So your machine learning code is usually very small parts of your system. If you try to bring your machine learning model to the production, you have to actually take care of a lot of different things that actually sometimes slow down your iteration of your model development. So like to talk about what's happening here. So do you see any problem in this picture or in this area?
I see a lot of problems in this area. Yeah, I do. But as far as what we're going to focus on the agenda today, ultimately, something like only 13% of data science models that get worked on ultimately reach production. And so we want to talk about some of the challenges that you see along the way that kind of stall this and that can kind of reduce the number of cycles that Moon talked about to ultimately get your model out there to production so that you start getting feedback from your users much quicker. So some of these challenges are things like data dependency in model training, model complexity, reproducing models that have been done before by training on data which may be moving and no longer available. Language restrictions when you're putting models into an embedded product. Monitoring models in production, and ultimately the DevOps portion, who actually owns it once it's out there. Finally, how do you actually test and deploy these kind of models?
So let's first start with data dependencies. And data dependencies are just a simple concept that what kind of data, how many data that your model depends on. So if you don't have a clear idea, that this becomes a problem on your iteration actually, because of data data can change, and the distribution of data changes. Maybe mapping of your data and your label might be changing, or any other characteristics of your data can change at any time. And if your model is not aware of that, then the next iteration you will end up with maybe very different results in your model. So understanding and keep tracking of data dependencies are actually saving a lot of your time in the next iteration, or the next iteration that other people will probably do on your model. So yeah, so data dependencies are kind of very important, and without understanding or keeping track of your data dependencies, your iteration becomes slow. And common practice here is actually keeping a burdened copy of your data. And people sometimes think that solves the problem, but it's actually, it helps reproducing your experiment, but doesn't not really help the iteration of your model development. So, but there can be many different ways to deal with these the data dependencies, but I think the easiest way is just document it or build a catalog. So I've seen a lot of teams and a lot of companies already have some kind of basic catalog system for the data. And the catalog system I've seen, for example, a lot of companies use Hive Metastore as their catalog system. Some companies use Glue, some companies use built-in in-house built solution for catalog data. But those catalog data usually have just a basic information, like name of your data set and schema of your data and what kind of field your data set have. But just adding annotations like what models actually uses this data, or how frequently this data is being updated, or maybe the distribution of data, or any characteristic of data is annotated in that catalog. It really helps. So that's it. Some low-hanging fruits you can do. And actually, if you don't have a data catalog today, there is a quick way to build it. And I'm sure most of the data scientists are familiar with data science notebook, either Jupyter, or Zeppelin, or any other data science notebook. And data science notebook is flexible enough, actually. You can build a catalog inside the notebook, and notebook is you can program notebook, so you can actually programmatically generate a preview of your data, but you have a flexibility to annotate any information you want. So this is probably a quick solution if you don't have one yet. In the end, you like to build a proper right data catalog system, but I think it's data science notebook is a good start to build it.
Yeah. And just before we jump to the next subject, we see this problem happen a lot with teams of analysts that are wrangling data, reshaping data, and getting it to a clean version that they ultimately trust and loan to someone else and then kind of start reusing it. It kind of creates almost a chain of dependencies that kind of live throughout the org. So that's something I saw a lot working with large teams of analysts. So one of the other challenges that you reach with putting a model to production is how to think about model complexity is very different when you're trying to build a predictive model that you're going to use on demand on your own terms. When you start putting things to production, you stop worrying about how important accuracy is because you really have to start thinking more like an engineer and really start thinking about the trade-offs that you have to achieve. It's really great to get that nice R² value that's really high and a highly predictive model. But when you start having to put things to production and you have to service 1 million requests a day, you're going to have to make some trade-offs and maybe get a slightly less predictive model, but a much more functioning. And so it's not always the same person who's able to kind of think through both sides of the problem. Sometimes it's one person who's able to really think through the right way to get a predictive model, but who ultimately kind of implements it, deploys it, serves it, can be a different person. You have to think through what kind of load is this model going to face in production? What kind of infrastructure do I need to support it? How do I evaluate this before I have any data about my users and how they're using it? And ultimately, what's the cost benefit? Is it really worth it to put this model to use at scale the way I want? These are tough questions for most analysts to answer on their own.
And we can also talk about the reproducibility. And I think many people here often face a situation like this. Oh, I can run my code or my project or my notebook in my laptop, but other people cannot run the same code, or able to run but getting a different results. So that's it, I think. So your model iteration, actually, model development iteration begin with the reproducing the previous results, and then you can actually improve your model on top of it. So reproducing the previous experiment is, I think, the first step, and if you cannot do the first step, you cannot improve your model. So reproducibility is really important, and it's actually not really difficult to address the reproducibility. So we can identify some problems that cause make things hard to reproduce. And one first thing is that runtime environments can be different. Your operating system or your language versions or your libraries, they can be different, and they can cause some code is not running on one machine but other machine able to run, and even sometimes when library version is different, you end up with different results. So that problem can be addressed by, I think common typical solution is containerize your runtime nowadays and run your workload, your notebook, your project inside of a container or Kubernetes cluster. That's, I think, common solution, and that works really well, I think. So if you take care of the reproducibility, I think containerize your runtime is the first thing you like to do. Another one is not always all the resources you can use, like compute resources, are available. So memory, amount of memory you can use, or the special hardware like the CPU is not always available for all. So even if you have access to it, other people might not have an access to it. So it's hard to reproduce who doesn't have that access to the resource. Also, the same thing applies to the data. So you may have access to the data, but other people may not have the access to the same data. So addressing that problem is actually, if you are moving your runtime environment from your laptop to the server side that everyone can connect and share, that's easier to actually address. So server side, we can almost guarantee that resources are available for everyone, and access to the data is actually easier to control on the server side because of
I have you guys here. Can you also try to talk as close to this thing as possible?
Yep.
Without being, weird about it. Thank you so much.
Sure.
Okay. Yeah, so access to the data is easier to control in the server side because of the if you are dealing with critical sensitive data, then you like to restrict the access physically and also via your ACL list. So it's easier to apply in the server side instead of applying all the security and firewall and all the access control list on individual's laptop. So that's a general way to address this one. But especially on the data science Moonsoo, I think a lot of data science Moonsoo I see on the GitHub, it's hard to run on my laptop.
It's some notebook I can just download and run, but some notebook it's hard to run because of I have completely different set of libraries, and library is not installed on my laptop. For example, I have to manually install. So I think there can be I propose some common practice for the data science notebook. That data science notebook nowadays, either it's Jupyter or Zeppelin or any other notebook, have a capability of inline configuration and capability of inline installation of the library. So there is no reason not leveraging that. So in notebook we can actually embed the environment configuration that we need, and also able to list what kind of library we need, and then we can start our work. And in the end, for documentation purpose, we can just print the versions of libraries or environments that we are dependent on. So I created one example here. So actual notebook can be more complicated, but for example, I can, this is not a real access key and security key. Don't try this.
Yeah, zoom in.
Okay, yeah, this is not real one, so don't try this. And we can configure the environment variables or the requirement of the cluster resource that you want to use, or any other dependencies. Like for example, in this case, we are defining that we are using Python 3.4 and depends on some library with specific versions. And this notebook is running inside a container, and it will always run exactly the same version, exactly the same environment. So you can expect the same results always from the notebook. And once you have done just documentation purpose, just one command, pip list, or if you are using conduct, just conduct list to document your environment. That really helps once other people are trying to reproduce your work. So I think it's a small, easy things to do, but it really helps.
Yeah, and sometimes you do a lot of work to write a great model, and you have a product manager that comes up to you and asks you, yeah, if you could just go ahead and rewrite this in Java instead of Python, that'd be great. And all of your favorite tools and packages that you've kind of come to rely on, you've got to shift your way of thinking, and you've got to re-implement it. And that can be really challenging and really scary, and not everyone is kind of up for that. And so this is not uncommon when you start embedding models that you kind of prototype quickly with these kind of modern notebook tech, and ultimately deploy in something on-prem, for example. We went through something similar after my last company got acquired, Perspica, where we had to translate some of our AIOps machine learning models into the new code base at AppDynamics. And so to kind of fit with some of the requirements of our legacy customers, really had to make it work with a lot more restrictions than we were anticipating up front. So just something to be aware of when you start dealing with more restrictive enterprise customers, that you don't always get access to all the tools that you have come to rely on over time.
And monitoring, let's say you have deployed your model to the production. Your model is working on the production, and users are, some other systems are sending a request to your model. So if there is only one thing that you can monitor, what do you like to monitor? And anyone have any idea what you like to monitor your model? So I think that there are hundreds of different metrics you can choose what to monitor. And actually, more you can monitor is probably better usually. But I think if there is the most important metric that you need to monitor, I would like to select, I can select one. This is maybe arguably the most important metric that you like to monitor on your model, which is prediction bias. So this is simply average, distribution of your predicted label, probably or usually the same to the distribution of your observed labels. What this means is, let's say I have a model that identifies puppies in the picture, and we know that, let me assume that we know that 1% of the total pictures in the world have puppies in it. So my model, I expect in any cases, my model will give 1% of input pictures. Out of, let's say I have 100 pictures, then probably one picture will be, my model will classify one picture as a puppy. If I have 1,000 model, maybe 10 picture will be classified as a puppy. And that's it. Because of I know the real world distribution will somewhat like 1%. So if, let's say I have another iteration and I improved my model, and my model suddenly giving 5% of picture is included puppies, then I immediately know something wrong, right? Something wrong with my model. My model have a bug I need to fix. So this is, I think, probably the simple but really important metric that I like to monitor. And once you monitor this one, then you maybe like to have something like an action limit. I linked one of the news article on the right, and some company a couple of years ago, which is a trading company, lost 440 million in 45 minutes. And probably they didn't have a prediction bias, and probably they didn't have action limit based on it. So what happened here is they deployed their model to trade, and the model starting to lose 10 million every minute, and in 45 minutes then they lost $440 million. I think if they had some kind of a prediction bias that says, oh, my model cannot lose more than, for example, 2 million in a minute, and they connect to their action limit. If my model loses more than X million dollar in a minute, and then it triggers alarm and waiting for the manual intervention, for example, and then they probably could able to save their company, but maybe they didn't have this one. So I think if your model have a real world action based on the output, then I think it's a really good idea to put your action limit, and maybe action limit can be based on your prediction bias.
So going through this loop and getting that feedback is challenging enough when you're at a digitally native, tech company where you have the ability and you're empowered with all the tools to do this on your own. It's even more challenging in highly siloed organizations where handoffs need to occur for each of these steps to happen. So when you have to kind of give your model to security and they don't truly understand the business questions that it's trying to solve, and they hand it off to QA to validate for something else. Ultimately, your IT operations team is the one that puts it up into production. They're so disconnected from the problem by that point, they wouldn't even know how to kind of catch and monitor some of this observation bias that Moon is talking about. So it's great when you're a data scientist or a team of analysts and you can kind of still manage this entire loop on your own, because as soon as you start doing handoffs, it gets much more difficult. And
I'd like to also talk about testing and deploying your model. So I think it's a really common practice as a software engineer that once you write the code, you write tests also, and your code need to pass the test, and then you deploy. Sometimes the deploying is, we often hear about CI and CD, continuous integration and continuous deployment. It's really common in the software development cycle. But it's not too common in the data science modeling, I think. So I like to introduce some of our efforts. We did some experiment work and implementation with the Apache Zeppelin community about how we can improve testing and deploying. When you develop a model for when data scientists develop a model. So this is the basic idea is data scientists uses many different tools, but notebook is one of their primary tool. And notebook usually, as far as I can see, a lot of notebooks in GitHub doesn't have any testing, right? So it's not really common to have notebook to be have an automated test, but we like to bring that some good practice from the software engineering to the data science. And another one is software engineers are, I think it's nowadays more and common to deploy themselves, deploy their code to the production, because there is some safeties that prevent breaking the production system. I think test is one of the safety system. There is a
question in test. Data science usually means test on new data for accuracy or generalization. Software engineering usually means regression testing on historic data to get the same results.
Right.
What test do you mean?
I think that's a great question. So data tests for the data scientist and tests for the software engineer might be different, and I think it's actually true. But what I like to do is, for example, even a data science code, modeling code, there is a very basic functions like converting the date. That can be a smallest pieces of software, and also we can actually test some, for example, prediction bias. Once you got a model with some portion of the data set, you can test, you can validate your model. So to not break the production, in a completely different way. So I think there are many things you can put in the test. Probably data scientists know what need to be tested more than I know, but I know that somehow before you put anything in the production, you need the code or the model need to be tested to go to the production. So I like to. That's a really good point, but I like to not go too deep into what we actually need to be tested. But I'd like to introduce some framework. This is maybe one of 10 different ways, but I'd like to introduce some framework that data scientists can put their own test. Does it make sense? Okay, so general idea is notebook can be tested. I think it's not really hard concept. And another one is once notebook is tested, I think bringing your model to the production sometimes it's really easy, sometimes it's really difficult. Some company ask you rewrite your model in the C++. Some companies just let you deploy your model, your same TensorFlow model to your serving infrastructure, which is not very difficult. So a lot of companies have different policies and process how bring your model to the production. But what I like to focus is data scientists, once they develop the model, it's supposed to be as close as production. It doesn't necessarily be rewritten with different languages, because that brings more problems sometimes. So like to, with the Japanese community, we like to experiment or propose some system that helps data scientists test their model themselves and put the model into the production themselves as much as possible. So let me share the concept, how it works. So let me increase some font. Yeah, this is just a notebook. You can see there is a really simple dumb classification function here. Probably in the real world, you will put your model here, machine learning model you trained with your data. But in this case, I just put, just handwritten rule here. So I'm classifying an input text. If the text is longer than 5 characters, it's true. If it is not, it's false. So it's a really simple text classifier. And there is no reason not doing writing any sort of test here. And this is one kind of annotation or one special feature that adding this function as an endpoint. I will explain it later. But writing this test doesn't mean that it will make things safe. Writing test means tests need to be executed before you deploy your model. So one thing that we introduced, the concept that we introduced is, let's say I modify the model, or like actually I should modify the model in this way, and let's say I create a revision 6, and then before deploy, I have to run the test. I have to pass the test. I think it's a really common thing in the software development, and this is a simple set of tests, but you can actually go more complicated here. So I expect tests will be failed. Actually, all these tests are running in a separate pod, separate container in the Kubernetes cluster. So anyone who runs the test, the result will be always the same. So it's a fully reproducible notebook. And once it takes some time to run the test, but let me run another one with the correct code, which will be revision 7. And I'm running this one as well. And let me check if actually my machine is running the test. Yeah. So revision 6 is failing because I changed my model in the wrong way. And the revision 7 will pass the test because I corrected them right. So will take a little bit of time to run the test. So I think this is just a simple test infrastructure embedded in the notebook, but I believe this encourages data scientists to run the tests against their code and their models, and that will bring the notebook one step, little bit more closer to the production. I'm not saying this is perfect for the production, but at least it's much closer than before to the production. So once the model passes the test, then the system probably have a deploy button to the production, or maybe a staging system. It depends on your situation. So let's say I click start serving in this case, then I see this green dot that my notebook, actually the model inside my notebook is being deployed and up and running here. And I have an endpoint to call my model. And let me actually try to call my model here. When I call my model with a long text, I can see my model returns true. And if I call my model with a very short text, like a short input, like a 2 character, I can see my model returns false. So once I deploy my models and I just call my model a couple of times, and I get the metrics on my model. So I can see number of requests, and I can see latencies, but what I like to see is how my model is performing. And actually you can put your own metrics here. In our case, we put a metric is how much my input is far from, how far my input is from length 5. That's it, the monitoring value at the moment. But in real life case, you will put more practical data to see how your model is performing. So in this way, you can monitor how your model is performing. So you can imagine that when data scientists have an iteration of developing a model, when input data changes or applying new algorithms, then you can see how quickly data scientists can have a iterate on the model deployment.
Oh. Yeah. So some takeaways from our. Oh.
I guess I don't know if you covered this, but what modeling infrastructure is already incorporated in your Zepl? Like, I can kind of gather that simple R script, simple Python script, which are just reading from some CSV file. That's all you do. Is there support for something bigger, like say you need to access TensorFlow and you need to read data in streams from the disk, because the data is like 12 gigabytes and you can just read it in 1 shot?
Yeah, great question. So the question, Moon, and I'll let Moon answer this one, is about, okay, this is a really simple model. What about with more complicated? What about with larger data sets? What about with more sophisticated, more modern frameworks? What's possible? This is a really simple workflow, but what else is kind of possible here? Is that?
Yeah, not just in the testing side. The testing side is valuable, which is good, but the model side of the
So what can we push to production right now, basically, or put to model?
Support as far as modeling infrastructure, like TensorFlow or PyTorch or the kind of APIs that they support.
Yeah.
Dictionary and so on.
Yeah. That's a good question. I think this is maybe too simple example, but I think the key here is you can define any Python function here. Your Python function, inside of your Python function, actually you can load a TensorFlow library or PyTorch library, and you can read pre-trained data, or you can train there. However, you can load your models, TensorFlow model or any other model, and actually you can write a simple Python wrapper here, and the argument of your Python function will be HTTP request body will be translated into the argument, and your function return actually first argument of this is returns tuple. So the first item in the tuple is actually translated into the REST API response body. And the second one is a dictionary, and the second one will be consumed by the metric system. So actually you can load, as long as the memory of this runtime allows, you can load a complicated and large model with TensorFlow library or PyTorch library, the library, whatever library you want. And there is actually very small limitations, like almost only limitation is your computing resources, I think.
Sorry, I arrived a few minutes late, so if you covered this already, then I'll talk about it later. But I'm curious about the versioning. Looks like you guys have one on the notebook, because I feel like Jupyter is very weak version control, and so I'm a little curious how you guys have solved that problem.
So the versioning, the question is how we solve the versioning, right?
Yeah.
So,
like you're actually working with, there's several revisions up there.
right. So Zeppelin have a pluggable notebook storage layer. So there are a couple of implementations, like the basic implementation is a local file system, another implementation is a Git repository, another implementation is S3. So you can actually plug in your own repository to store notebook, but storage layer, when you extend, you can choose just a simple storage or versioned storage. So in case of a Git repository, it implements versioned notebook storage, and in that case, you can see this versioning, buttons on the UI. So it depends if you are using the notebook storage that supports versioning, then you will be able to see those buttons on your user interface.
And that's for Zeppelin. For Zepl, our enterprise product, we support the same functionality, but we also kind of keep a Google Edits kind of style, keep your revisions as you go kind of history. So that way you don't need to remember to hit save at that critical moment. You kind of have access to all your revision as you kind of work through finding the model you need. So.
You also mentioned you had data versioning.
We do consider data versioning like a really important aspect of kind of making sure the right model goes to production. So one of the pitfalls one of the quick solutions that we talked about was just keeping literal copies of data as you're working through each of the steps of your analysis, so that you can kind of revert to an earlier state. This is really important when you're working with sets like streaming data. So Moon, do you want to talk a bit more about that?
Yeah, I think that's a really good issues, how we want to take care of versions of different data. But also, it's, at the same time, it's a really difficult issue to solve because of all the data. When data is small, it's easier to keep a copy. But when data is really big, it's difficult to have a copy of that. And the storage system data stays on is always different. Some data are, some people use S3 to store data. Some data are on the SQL database or SQL-based data lake. And some data are on the somewhere in the completely different format. So sometimes storage itself supports snapshots, for example, that helps keeping a copy of data. Or some database system or data lake system supports keeping a delta, only delta of the data, so you can go back to any particular point more easily without storing full entire copy of data. And so I think it's really tightly related to connected underlying storage system or data source that you are using, and managing the list of the different versions of data. That's, I think, another thing that on top of this story. So it's a really good topic. We like to address some someday, but it's also really complicated and difficult topic, I think.
Great, so just kind of the key takeaways from our talk. Think beyond the algorithm, think about the trade-offs, especially as you kind of move to put your model to production. What works in development will likely not work immediately in production, so move quickly to get a couple cycles and to get that feedback quickly. And ultimately try to apply some of those software engineering best practices to data science. Cool. Thanks, everyone.
Also, thank you, Zepl, for sponsoring the pizza. Please give applause. Appreciate that. I have a book drawing. So this would be for the ECM member, if you're a member of our local chapter. So since we didn't pass out tags or drawings, I'll do it by birthday. And no, I'm not going to look at anybody's year. I don't know how to read that. Just month and day of month. So this is what you'll read. So I generated a random number, multiplied it by 365, converted it to month and day. So who's closest in their birthday to January 25? Raise your hand. Anybody within, how close are you? Oh, that's anybody closer. How close are you? What's that? Oh, okay. So, well, I guess we have a winner. So thank you very much. Most good I've ever had. Also, Leanna, did you have any announcements? Were you looking for a location for one of the meetings?
Oh, yes. Right. We do need a location for our August talk. August 15th, I believe, is for computer architecture side. And it basically talk about how to compile the C code directly onto chips from standard library. If anybody have locations, please contact us, or we can have another talk.
Okay. Well, thank you very much. Feel free to take some pizza home with you or any other snacks that are left. So thank you for coming tonight.